Welcome everybody today to Novatec All In. Every time we do one of these podcasts, we're going to have a special guest focusing on conveying, blending, and drying. We had a customer in recently, and that customer said this was the best day that they've ever had of getting information from the supplier. So this is our way of trying to make that happen virally for all of you out there.
Cheers.
Today we're talking with our special guest, Ryan Ismirlian, and we're talking about dust collection.
Buildup of dust causes slowdown of airflow. Slowdown of airflow causes loss of cooling. Loss of cooling causes heat. Heat causes fires.
It's also important on what micron level we're talking about.
Each cyclone is designed specific to a certain size of particulate.
Let's talk a little bit about cyclones. So I just want to welcome everybody today to the first edition of Novatec All In. And I had this idea as one of the owners of the company that we had such tremendous experience at all of this, specifically in our conveying, blending, and drying areas. And it came to roost when we had a customer in recently, and that customer brought some extra people in, and we just had a brainstorming session. And that customer said this was the best day that they've ever had of getting information from the supplier. So this is our way of trying to make that happen virally for all of you out there and take benefit from all of our experience. And with me today, and by the way, I'm Conrad Bessemer, one of the owners of Novatec. And I've got with me today Tim Noggle, who's our VP of Sales, and Greg Washburn, who's VP of almost everything else, and operations, but specifically engineering. And when I think back, it's been almost 20 years since we came in here and bought Novatec, okay, my partner and I. And these two guys were pretty much here at that point in time. And it's been a journey. It's been a real journey of learning about Novatec, learning even more about this industry, and focusing on conveying, blending, and drying. And that is exclusively what we do. And so every time we do one of these podcasts, we're going to have a special guest. And today, after we talk about our backgrounds a little bit, we'll introduce our special guest here. But my background, I unfortunately have almost 50 years in this industry. I say unfortunately because it's a long time, 50 years. And 20 years practically here at Novatec. The prior 20 with Conair. Many of you know that. Leaving Conair, I was president of North America for Conair. Came here for the opportunity to actually participate in the ownership of the company and redirect Novatec, take it where we aspired to be. And that's been a great experience for me. I think back of Conair days. When I joined Conair, it was 1/4 of the size when I left. But we did that at Conair a lot through buying other businesses.
Certainly differently than it's been done here, right?
Amazingly different. We haven't bought anybody. We've done it all organically, the old-fashioned way. We get really focused about our products. We build better products. We built that market share, and we grew this business. That's enough about me, but let's talk about Tim. Tim, you've been here, recruited you from day one, I think. Okay.
Yeah, we've known each other quite a long time, and through shared wins and miseries.
Yes.
In the past. But yes, I my background is a little bit different in that I came from the processing side of the business, in operations and engineering. And I always joke with the guys around the table that I wasn't always a used car salesman. I had a real job at one point. But came into the machinery side of the business through Graham Engineering, which is where you and I got to know each other, through some shared customers, and then have been here 20 years with you and Greg and a lot of other people growing this business and working hard at it. So it's been a nice focused journey for us. It's been a journey, but it has been a focused journey in that we have never fallen into the trap of getting too far distracted from the core of what we do. We don't try and be a water company. We don't try and be a robot company. We have great partners who do all that. And if we need to make that part of what we do, we know who to go to that's an expert at that. And I think that's been an extremely important part of our success in growing the business, is being a true expert to our customers, rather than trying to do everything for them and maybe falling short.
Before I let you go, and we talked about Greg a little bit, I just want to drill back to, yes, we met at Graham Engineering with a mutual customer, very large customer, automotive customer. But what especially impressed me about your background was what you did prior to that, in working in plants, and so you knew the process from the ground floor.
Sure, yeah. I mean, I was in both injection molding and blow molding with Lear Corporation. Started out when I left the military there, and grew through their engineering organization. But then had a chance to do a stint down in Kentucky at Infiltrator Systems, also another great partner of ours still today, and got some enhanced experience there in both extrusion, helping them with the startup of their compounding and recycling process, but also gas assist injection molding, which was a whole other aspect of that. So yeah, I've been very fortunate to have been exposed to a lot of varying processes, and both lived through them, but also hopefully provided some
it
value.
brings a real perspective to it. And it goes for a lot of our project people and our regionals who have that background. They know the process, and not just having been in this industry, but they know the process as well.
Absolutely. Yeah.
Because I remember when I was in my 20s being in the wire and cable business and early jacketing, there wasn't as much plastics out there at that.
Sure.
Because I remember Don Graham just starting the business back then. And then on Greg, you're actually, I think, Novatec now. How many years total?
31.
31. So you beat any of our tenures. But certainly, you think about those 31 years. Just tell us about some of the what you found, the differences from when we started and where we are now.
Well, that's the thing. And just listening to Tim, the difference for me has always been just the fact that, I mean, I've been here since I was 23. So, I mean, I literally started here out of college. So I tell the story all the time where, I came for the interview for Novatec during my finals week, my last semester in college. So I got the job, and they were like, so I was always trying to remember if I got to go to NPE in 94, but I didn't, because they made me start after that because everybody was at NPE. So they were like, start the week after.
Yeah.
So from 97 on, I got to go, but I didn't in 94. And that's one of the few times I get let out of the box. So that's the part that I've always enjoyed about going to the shows and the times I get to see customers, because I don't have the experience that you have, right? I don't get to go out there for experience. Because I've always kind of been the inside guy doing engineering and operations. But in Novatec, from a historical perspective, I always enjoyed because we were an engineering company. I mean, we engineered a ton of stuff, probably not too much. And that was always the part that transition of pre and post Novatec, because, I had the 12 years prior to when you came, Conrad. And during that time, learning how to rationalize the products to become more of a customer-focused piece that you could really look at. We can do that too.
In the early days, you're a project guy.
Oh, yeah. And that's, 80% of what went through the company was engineered, in some fashion. And it was small stuff a lot of times. And we did a lot of what we would call mods today, small stuff. But at the same token, it just made it very, very slow and methodical business. And it was great. We did a lot of niche stuff. We took the stuff that nobody else wanted to touch.
Which was really cool stuff.
And I think the part that I enjoyed the most after the acquisition was the fact that it took us a couple of years, but we really started to learn what Novatec was good at before then and what we could be thanks to your input, to all the impact that Tim had as far as his knowledge of the marketplace and the guys that are on his team now, which was a completely different set of guys than what we had in here before. It was just really, I would say, guys that knew unit business, but not how to sell a system or, really expand what we're trying to do. So from that end of it, doing $12 or $15 million to what we could do today, which, obviously could be $50 or $60 million, was just a completely different mindset. But we do a great job, I think, in this point of some combination of great standard products, thinking about what the customer needs in general, but still using our in-house capabilities to tweak something, to do something on the fly, to make something better or fit in a corner for a customer that our competitors don't do well.
And it's probably almost half of what we do. So, depending on the projects that come in, but it's easy to do, right? I mean, just because of the way we approach the business. One, your guys still make everything, or a great percentage
big portion of it, right?
And so, when we pop up and say, the customer loves this, but they need the door on this side instead of that side,
we can do that.
Doesn't set the whole apple cart, right? I mean, you guys just do it
100%, and that's always been our advantage is we can do the right hand and left hand versions of something, and it doesn't throw a giant monkey wrench into it. Does it take a little bit extra time? Sure, but at the same token, we do that almost as seamlessly today as people do standard products, which I think is just an important value that we can bring to customers.
As much as it's great to be a vanilla company where you always make the same thing, I mean, we obsess over the individual customer application. It's what we do. Tim and the team talking about different folks out there, and we'll talk about some of those people later on. But what occurs to me when I look at all that, and just the three of us, and before we even talk with Ryan here, it's over 100 years of experience sitting, just the three of us. That's unfortunately, I'm like half,
for better or worse, right?
and my hair obviously shows that, and everything else. And these guys put up with me every day, but I've learned a lot from them as well. But I think at the end of that, with that, from the very top of this business, what makes us different is that experience. I don't think there's anywhere else in this industry you can go and find where the owner/president of the company is active in the management and everything else, that the VP of sales and the VP of engineering have that raft of experience. And it's that soul of this business that I think sets us apart, and that I'm trying to portray to our audience that's out there, because we don't get to see enough of those people coming in here. Absolutely. And God knows that Tim and the group, they're out there all the time. Greg, you had a recent trip, and we'll talk about that trip later.
They were in drag. We're dragging Greg out more and more.
Yes, it's great to see, and solving customer issues. And one of the customer issues we're going to address today is about dust collection, which is a huge issue in this industry.
Seems fairly simple to the point where people almost don't even think about that issue, but until they have to think about it. Right.
Yeah. And it's just all over. But we'll get into that. Yep. But with that, I want to introduce Ryan Ismirlian, who's right over here, and sometimes I call him a product manager for our conveying line, but he started with us as a conveying product engineer. He's been with us.
It's 11 years today.
11 years today. Well, that merits a celebration anyway. So we were normally going to have a beer tasting that we'll all toast to Ryan's 11th birthday with Novatec.
Nice.
Anyway, it's great, and it's great to see Ryan evolve from. I remember when we first.
I remember your interview.
In the interview, and encouraging him a little bit, because I think it was the first job at that point.
Not really. First full time.
Full time.
Yeah, because you kind of grew up in in a hands-on business, right, with the family and
I
so.
did, and spent some time in the paper industry during an internship.
Yep. Yep.
I had grown up in Worcester, Massachusetts, and Ryan was actually graduated from Worcester Polytech, which is a great engineering school.
Yep.
And he certainly applied a lot of that along the way and learned a lot and brought a lot to us that we'll talk about. So
Robert's not putting enough pressure on him because his hair is way too dark still.
well,
I would start going gray at 35. So
It's not as dark as it used to be, I'll say that.
anyway, so Greg, you work with Ryan every day, and background with Ryan and what type of project he works on.
Well, obviously, Ryan handles almost all of our conveying products. And I think the most impressive thing that Ryan always does is his attention to detail. And that's been really the case since day one. I've seen it in almost everything that you work on. I mean, I can hand over, Ryan and I can have a 10 or 15-minute conversation, which happens often. And when he comes back to me, everything is laid out systematically. He has all the numbers. It's full background and details and justifications, but then looking for input too. So he's never decided that this is the best thing. It's exploratory on every engineering level that we need to be able to know. And I think that's the important part, which I think is why you're so good at applications, because it's one thing to engineer products. It's something else to really comprehend the full application and then apply our products to the best of their capability and then know how to modify them. And I think that's what you do extremely well. And that's always been, I think, the strength that you've brought to the table. And why really, to Conrad's point, you do product management as much as you do engineering. And that's just been the transition that just naturally occurred over the years because.
That's the background makes all sense in the world, but I don't want to talk too much about Ryan because pretty soon he'll be edging me for a raise here.
Instead, we'll celebrate that birthday celebration. And Ryan brought a bottle opener.
He's still young enough for that. He's still on my team.
And so it's my turn.
It's my turn. Your turn to bring the beer.
So I anymore I drink non-alcohol beer, but I occasionally buy it. But Tim's probably the expert beer drinker here, and Ryan, Greg, and Heinz are. But this is actually from Kansas City, Missouri.
Yeah.
So
little shout out to our reps out there, Mike Marock and Dusty Meyer.
Nice.
Want to make sure we recognize the expertise of their region. Bring us some great
Bourbon Bear Quad from Missouri Smokestack series. So
Going pretty strong out the bat right here.
12.2.
Yeah, the first one of these that we're doing, and Conrad volunteered to be the beer provider, and obviously has set the bar high for us.
Well, I set the bar high sort of because first of all, I do like bourbon, and I know Tim does. I was with him on Saturday night, and so I'm ordering some.
Yep.
So, and
you're serious enough about enjoying our beer that we have Novatec branded glasses for our friends.
So now, need to critique this a little bit, folks. Sure. Right? Because so many different. I had no idea. I mean, I walked in the store and never realized it was in rows and rows and rows.
Amazing.
And then they tell me, well, beer industry is struggling a little bit right now. I can see why, because
so many competitors.
Yeah,
it's crazy.
Anyway, so first there's from Ryan. To Ryan, 11 is Lord David Roots. Okay.
Oh, that's nice.
That is good.
That's interesting. A little sweet.
Yep. It does have a little sweet.
Yeah.
To it.
Yeah, that's nice.
Really smooth though.
Not really what I
That
expected.
bourbon aftertaste.
Yeah. It's a little softer.
It is softer.
I think this is a winner.
I think that's based upon it. And
It also good just for me.
No, that's a good one.
it is good.
It's good. So
I like heavy beers too. I mean, obviously, spending a number of years in Germany, I got used to a little more body in beer. I like this type.
Yeah, it's good.
Yeah. The fact that it's an ale, I think, is what keeps it light.
Yeah.
Because it's not a stout.
It's not stout exactly. Yeah.
So anyway, I guess I set the bar reasonably high.
Yes, you did.
It'll be well done next time.
Absolutely.
And we'll see what you
And pick another region on that.
at.
Yeah.
And We'll try and knock you off that plateau a little bit.
Maybe we'll even let our marketing manager, Dana, have some beer next time. Not this time.
All right. With that, we will take a little break, and we'll be right back. So welcome back. This is Novatec All In, and today we're talking with our special guest, Ryan Ismirlian, and we're talking about dust collection in plastics plants.
Yep.
And this is something that has accelerated hugely over the last 20 years, I would say, with reclaim being more and more part of that industry. And then we have that with customers. In-house reclaim, obviously commercial reclaim as well. Fines, dust generally, but by and large, dust is found almost everywhere. And plastic, absolutely. So, I mean, Tim, you're out there all the time.
Never-ending battle.
Talk about
Never-ending battle.
Some of the plants you see.
Yeah, I mean, it's we certainly the amount of reclaim usage fluctuates with the price of resin sometimes. But in general, I don't know that there are a lot of industries that don't want to reuse at least what they're producing, if not not necessarily bringing in reclaim, but at least using their trims, their screws, right? Exactly. And so there's always that challenge of both central granulation, where you just take it into a room and hide the mess and deal with it in one place, or if you're grinding out beside the press, and then it becomes a whole different issue of trying to keep that dust contained within the confines of the process. And then there are some companies that want to get rid of the dust. Some companies want to keep the dust in. Dust is certainly pounds of resin if your process can deal with it. But especially clear bottles, clear sheet, things like that, usually you want to separate those fines because they could create imperfections in the visual aspect. And so you give up a little bit in the pounds. So it's always a challenge of do you abate the dust at the process, just filter it and blow it back into the process, or do you try and pull it away and take it central? I think most molders for sure, and even most sheet extruders probably are of the opinion that getting the dust collected in a central location where you can deal with it is probably easier on the process. You have less people who have to be engaged in it, right?
And just one of the subjects we talked about several weeks ago was about noise and sound abatement.
Sure.
Plastics plants.
Yeah.
And in many respects, sound was an issue, but people just thought they had to live with it. Okay. And I think the impression I have over the years is that people have just gotten used to this dust issue.
Yeah.
And they sort of put up with it.
It's a necessary evil, right?
A necessary evil because they didn't really know how they could improve the process, what they could do, what machines out there. They may have tried a few things. They didn't really work that well. So that's one of the reasons we want to be here today.
Sure.
It is everywhere.
Sure.
And there are some new solutions, some things we've done, some things other people have done, and that's what we want to talk about.
Well, I think it depends where in the process you're also trying to deal with it. In terms of, if you're trying to deal with it in at the granulation point, or at the size reduction point, however you may be doing that, it may be pulverizing. There are a number of ways to do that. Passive and active. We usually, if we get requests for us to include granulation in a system, our first go-to in that kind of situation would be to call our partner Kongsguild and use one of their elutriating systems. Not the cheapest thing in the world, but certainly extremely effective because it's zero pressure. You're not blowing dust out anymore. But if you're dealing with it in the conveying system, after that point, or even dealing with dust from virgin resin, or dealing with it in the drying process where you're getting dust coming out of a drying hopper, whole different scenario. And I think that requires a little bit different approach. The very traditional approach of baghouse filters is semi-effective. A lot of maintenance intensity to it. Right? You got to be tending those all the time.
And that's the stuff that we would see more classically probably in the 90s or the early 2000s because maintenance people were more prevalent, right? It was easier to do that at the time. So I think collecting it at that point in time has a different perspective than today, where maintenance people are, just scarce. I mean, you can't find them.
Absolutely.
Nobody wants to shut down a line. Nobody wants to have maintenance people. So trying to find cost-effective ways, exactly to your point, to either abate that in conveying or drying, which is the stuff that we would typically supply, is an important part of it. So.
Yeah, I mean, normally, if you in the 90s, you would go into a injection molding plant or an extrusion plant that was handling a lot of regrind, and you always knew where the drying hopper was because it had the black wall behind it or the blue wall behind it, whatever the color of the resin you were running. Because even if you were filtering that stuff, you're not filtering all of it, and so you always had that cleanup issue. And today it's I think a different story and a different approach, mostly because I think we understand from an engineering standpoint much better how to deal with airflow, because we have such great modeling tools now. So we have a lot more information than we had in the past. I mean, certainly we're doing a lot of that with drying right now.
It was an idea of a typical plastics plant. What are the typical reasons you're getting dust to start with?
Sure. So, I mean, and Greg, you've just seen some of this firsthand. You were just out at some plants in the Midwest.
Yeah.
But a lot of it, I think, coming even starting right from the source where the resin is made, right?
Well, and it was twofold. Actually, we sold 2 customers during the trip, and the first one actually had edge trim, and they were actually, all of that regrind was happening right there on the floor, and they were trying to reincorporate that as quick as possible. And then at the secondary plant, it was more, I mean, they were pulverizing. I mean, and they really were trying to regrind it, but you could definitely tell that their blades were not extremely sharp, and there was just a sporadic.
So talk about what happens with granulation.
Yeah, I mean, that's the biggest challenge. Go ahead, Greg.
No, go.
So, I mean, that's always the biggest challenge. And my first job in industry when I came out of the Army was as a maintenance manager in a plant. The never-ending saga and challenge of sharpening grinder blades, maintaining cutting chambers, maintaining the screens, and making sure that all the clearances in granulation are the entire clearances and the sharpness of the blades are the entire key to it. The tighter the clearance, think of a pair of scissors. You get an old pair of scissors, it's got a loose joint in them, and they don't cut very well because there's a gap between the blades, as opposed to a new pair of scissors, nice tight blades, and they slice right.
Heat regeneration, so you get
exactly.
As I recall, it gets smearing.
Exactly. Yeah. And once you get that jagged edge on a piece of plastic because you've stretched it and torn it rather than cut it, now that's just creating dust. All little particles come off that edge. And so that's always the
never mind what happens once you start to convey that.
Well, exactly. Because now you're gonna convey it, and you're between the changes in directions and piping and so forth, every time it bangs into something, it's going to want to fracture and create more of that dust.
Right. So, like what we saw when I was in plant, a couple of weeks ago, was the fact that because the screens were not they actually had parts that were chunks and then parts that were bits and then just dust.
Sure.
Right.
Yeah.
So they're still trying to reclaim all of that and then convey it, which obviously has challenges. And that's a typical you get all the time at this point, right? Is just the fact that we'll ask for samples of what's being conveyed from point A to point B because of that mix of pieces. It's not a simple, well, what's the bulk density a lot of times, because the bulk density is going to be at kind of some type of homogenized number at that point because it's not all the same virgin pellet. It is something that is a combination of stuff, and that's stuff that you see weekly. I mean, I don't even know anymore.
Yeah, it really depends on when the inquiries come in.
Sure.
So it's frequent enough that I have to be able to provide that kind of information, or where we have to get more in just to do a conveying test.
Mm-hmm. Yeah. Well, and it's not just we talk a lot about regrind when we're talking about dust because obviously that's a very obvious source. But even customers that we deal with all the time that run 100% virgin resin. And they still have dust issues. They still have abatement issues. And talk a little bit, Ryan, about how does that happen? I mean, you're talking about virgin pellets. It should be nice and clean.
Well, there's several steps where it could be introduced. I mean, it could even be introduced from the main supplier.
Yes.
Especially if they're loading rail cars or something and they're trying to fill it at a high rate of speed, that could cause some of it. It could be the unloading of rail cars at the facility, whether that's through truck fill or through a rail car unloading system. Which that could be if you're doing pressure, you're always dealing with heat. So you might actually it may not really affect it as much. But if you're dealing with a really brittle resin under high pressure, you can impact it against elbows or against improperly fitted lines. Or if you're doing it via vacuum, it could just be from acceleration.
And an asterisk, this isn't an indictment on anybody in that process. It's just the nature of what we do and what happens throughout the whole process.
And also, every system is different. In that case, like you could have really long runs with minimal elbows, or some that are just jam packed with elbows because that's how they were able to fit their system.
Yeah.
And that is really the key point, right? Is the fact that sometimes it's not what we would ideally design. It's because this is the hand that you've been dealt.
You're dealing with the reality of what.
Right. I mean, there's a wall here. You got to make this corner. I mean, some of these plants are a mile long, and the only place where the rail comes in is down on the other end of the building. I mean, you can't help some of this.
Yeah, and it's not all isolated to the rail car side of it. It could be generated,
absolutely,
depending on how the system's designed,
of course,
what the material is, and what the practice was.
I think at the end it becomes all of the above.
Right.
You've got the transport, from the original plant to the rail car or truck or however they're having to be providing the material. And let's face it, people want to get things done as quickly as possible. This is America.
Time is money. Yeah.
This is America. People are impatient.
Absolutely.
If they can blow it out faster, they're going to do that. Mm-hmm. And then, once again, in the unloading process. Mm-hmm. So you're just repeating that same thing. Sure. And oftentimes, that unfilling is not in the plant's direct control in many cases.
Absolutely. It's usually third party.
Right. Yeah. Third party. And that truck driver or the operator there wants to get in and out as quickly as possible.
Yep. That's his goal.
And that is his goal. Is probably how he's paid.
Yeah. 100%.
Well, and so we get a lot of requests in systems, and Ryan does a lot of this for us and does a great job of calculating these things, where we have intermediary pieces within the system to kind of force a moderation of some of that enthusiasm, shall we say. We have pressure relief valves that we can put into truck loading lines, silo load lines, so that it will only allow so much pressure. So, we kind of force it to not exceed certain things. But even with those steps, that's one of a million things that could happen. So yeah, there are a lot of those types of situations.
The point is, it can happen in a myriad.
Absolutely.
Yep. There's no silver bullet here. No, for stopping that and doing one thing. You have to do a series of things better.
Yep.
Protecting your incoming resin. You're spending all that money on resin. The percentage of resin costs to a final product is huge. So you certainly don't want to waste that by reducing it to reclaim. And then you have a conveying system you're putting it into. You have granulators you've got to focus on. All those things work together. And is there anything else I missed in that that we find typically when you're out there?
I think those are the main ones, the highlights. Yeah, those are the high points. Again, a lot of it is the type of resin as well. I mean, certain resins are more susceptible to fracturing, like you were talking about, Ryan. I mean, what are some of the resins that are probably the most brittle that when we see those, we think there's going to be a dust issue we need to at least be aware of?
So one big one could be just if everyone thinks about PET.
Sure.
So, I mean, even a customer that I was visiting has PET dust everywhere in their system.
Yeah.
So, that would be
polycarbonates.
Polycarbonates,
right? Yeah.
Maybe acrylics.
Yep.
So,
yeah,
those would be a couple.
Sure. I think Greg, the customer you were at last week, not the edge trim, but the other one was primarily from a reclaim situation, I think, as I recall.
It was. They were doing containers that obviously they had a lot of splay problems. So they were doing a lot of in-house regrind, and so they actually were taking it and they wanted a certain percentage only to go back into it because then they blended it back into a certain amount. So they only wanted to see so much of that in the new product, even though it was in-house regrind.
Sure.
So they would come back through, convey it over to the blending section, get that homogenized with the right around percentage with virgin, and then take it back out to the lines. And they actually had so much dust problems. This was your classic setup of separate pump area, right? So it was behind the magic wall. So their pumps and cyclones were all back there before they went out, probably a couple 100 feet to get out to the main chains out on the floor. And you could definitely tell, which pumps and cyclones were running which material, because they were running some yellow bottles of a product that is very recognizable for what it was, and then some off-white ones as well. And you could just the collection
residue gave you a hint.
Could definitely tell what lines were running what.
Like a yellow snowstorm.
Yes, and it was a little bit everywhere. Enough so that they had cyclones and FDCs in place both. And then we can get into what both of those things.
We'll talk about those, and because obviously the rest of the world doesn't know what we call something FDC or CFC, and what is that? So we'll get into that.
Yeah, we start throwing on acronyms like we're in the military.
And hopefully some of those are put up on the screen for you, to look at. So, but now we've established that it's just this myriad of issues that we know there's dust being created. We know that's happening in the factory. Let's talk about why management in a typical plastics factory should care as to this dust issue that they've sort of put up with over the years, and how it can affect their process. And then more specifically, we'll talk about how it can even affect our equipment and the performance of that.
So before we talk about the process, because that's a good point, let's talk about how it affects their company overall. Right. Because I think that's important, and sometimes that gets lost in the frustration of dealing with it. We from time to time see situations where we'll have a company that we deal with who has had a fire in their conveying pump, and you trace these things back, and buildup of dust causes slowdown of airflow. Slowdown of airflow causes loss of cooling. Loss of cooling causes heat. Heat causes fires. And so there are real safety and danger issues involved with dust getting through a conveying system and into, say, the muffler on the pump. Where it now builds up, and you end up having a real safety problem and an insurance problem.
Well, yeah. I mean, I say OSHA specs on environmental qualities.
Yeah.
I know Greg, from an operations point of view, you know about some of that.
Well, that's what I was going to say too. Is not only do you worry about your equipment, but you worry about your employees.
Absolutely.
I mean, that's the other thing that was very prevalent in what I saw just a couple of weeks ago. Was a high dust environment, and everybody there had to wear masks because of the type of air quality that you had there. Air quality, sound, all those things have become just much more forefront as far as OSHA specifications, how much companies have to be aware of those things. I know, just from our own factory perspective, it is a high, just top of the kind of list of things that you need to be aware of all the time, regardless of how much work is going around.
Yeah, absolutely.
Any factory, you want your workers to be as healthy as possible, because it's hard to find good experienced people, and you certainly don't want to get sick or hurt by anything that you're doing in your plant.
Or drive them away.
Right, or drive them away.
Yeah, the cost of training a new employee is astronomical anymore. The last thing you need is because of your environment to drive them away from the process.
And particularly our customers that, the equipment is doing the value add, right? I mean, the employees there are loading, unloading, and they're doing the supplemental work. Mm-hmm. So it's a low quantity of employees as compared to space and machines. I mean,
sure.
The first thing that you always kind of see when you drive up to these places, it's this humongous building with very few cars there, right?
Yeah.
You're thinking, is nobody there today? But it's really because
automation.
Because
certainly, yeah,
it's automation, and just the fact that the equipment itself takes up so much space comparatively. So employees really become valuable. So when you lose a person or two, when you only have 20 people in a factory, it's a big impact.
Yeah, absolutely. I mean, you walk into a typical injection plant that's running, widgets. We'll just use the generic term widgets that are low value add. They're just shoot and ship type parts. you may have one technician, one operator running 4 lines, and they're set up in a work cell. Automation is really great anymore, and our colleagues in the injection molding or blow molding or extrusion worlds who make those primary machines have done such a fantastic job of automating those processes that you're right. When you have a person that's good, that person is responsible for a lot of value coming out of a work cell.
Right.
And the last thing you want is to turn that person over because you provided a terrible work environment.
Exactly. So in all that, it's pretty clear that plant environment is absolutely essential from just a plant point of view, safety point of view, industry point of view, and so forth, and so on.
Yep.
Then you go to the machines, right? And never mind the injection machines that are now have come so far and need good protection and everything else. But furthermore, obviously, most of all our machines have filters on them, but those filters are easily overwhelmed, by heavy. And then, so what happens when let's say in a dryer, the filters get blinded or start to get filled up? What happens with airflow? Just go ahead and explain that.
Well, but the bad part is, I mean, there's only a couple key aspects to drying, right? So you have CFM and you have heat.
And what is CFM?
So cubic feet per minute of
airflow.
All right. So you're just talking about sheer airflow there. So if you're talking about how much air, if you're looking at, for a longest time, and historically it was a CFM per pound per hour. I think commonly you'll find a lot of our stuff will have anywhere from 0.6 to 0.8. There's some competitors that have 0.5 or below. I mean, so it really depends on the resin that you're trying to handle at that point in time.
But that air is just trying to deliver temperature.
That's right.
And take away moisture.
Right?
Right. So as you start to blind filters, you reduce airflow, and as you reduce airflow, you reduce drying capacity.
Yep. Which is going to mean that it takes longer to dry something.
If you dry at all.
If you're drying at all. Okay? So even though it has a machine filter on it, if that's blinded off or compromised and your airflow is going to go down, you're not going to dry as well. Okay? You may think you're still drying because you're putting it in for a certain amount of time, but what you get out of the bottom isn't going to be as dry as it should be. And that's purely because of that situation.
So between airflow and contamination, when I say contamination, I mean
blowout and filters and so forth.
Or just if it's not a great filter, then you have the potential of killing whatever your drying mechanism is. So, whether that's molecular sieve, whether that's some type of desiccant wheel, certainly that we sell a ton of, those things then, if they start to receive this carryover of dust or anything else, and those things get caked, or I mean, then now you're just really killing the system.
Well, the same thing on the conveying side. You're getting all those lines and that carry over. The fire guys for that, and that's where Ryan's
have a lot of focus in on what happens with pumps and
right.
And it's a very similar to drying. I mean, you're focused on airflow and pressure generation, whether that's negative or positive.
Sure.
So you're creating a negative pressure. You want to be able to have that full performance in order to convey your plastic material, primarily through a dilute phase. I mean, there's some cases there are some dense phase systems out there. In order to pull that material through the system, and you have to achieve a certain throughput to feed your machines. Now, if you're starting to saturate those filters, you're starting to lose pump performance. You can't pull as much CFM through, even though you may be able to achieve the same vacuum load, because the pressure drop across the filter increases and you're actually losing that vacuum capability down the line. You're not pulling as much. You're going to start starving machines. You could start making the pump work harder, so you actually come into some certain failure modes where you could be overheating.
What happens with the pump?
The pump can overheat. You could have bearing failures. You could degrade the oil more quickly because there's more temperature in it, because you're not able to pull that heat out as much from the amount of CFM it's designed to do.
Never mind the conveying problems you're going to have by not the water material.
Absolutely. And then it's not even just at the pump. It's also at your receivers if you have that kind of filtration system.
Well, and the problem is really pretty widespread from a standpoint that one pump doesn't typically, in most plants, run one machine.
Right.
You may be running 10 machines off of that. And so you'll see degradation slowly over that whole line, right?
Yep, and that's the same for drying as well.
Yeah.
The filters are always a battle against performance.
Yep. That's a good way to put it.
Right. So I think then what's occurring now is to talk about pre-filtration, okay, in this industry, and not just accept the fact that you've got this filter in your machine and that's good enough, because that's what the industry has largely dealt with for years.
Yeah, I think everybody has a filter on most critical processes.
Yes.
Drying, conveying, and granulation, water. There's filters all through the facility. The problem is that they, in traditional filters, like a Donaldson type filter or some type of a positive media filter, they are always a trade-off between performance versus maintenance. And so, over time, those filters are designed to catch more of the contaminant. And as it catches contaminant, it degrades performance. It's just a natural phenomenon. There's no way to avoid that.
It's just like your home heating system.
Exactly. And so trying to abate that contaminant before it gets to that media so that you minimize that degradation of performance is really become the focus of trying to prolong the process. Prolong
filter work.
Exactly.
The whole goal of that is that people don't have to change the filters as frequently if you have some pre-filtration going on.
Exactly.
Because let's face it, when you're being paid to shoot parts out the door, changing filters is not something that you want to do.
Absolutely.
Right?
Yeah.
Changing filters is done after that fact. Okay. And so you're watching performance degrade, and you want to avoid that whole experience of changing filters as short as much as humanly possible. So with that, let's talk a little bit about pre-filtration and the products that are out there, and then we'll also talk about the products that we don't make, for example, and on the elutriation side and so forth, and then the people that are focusing on that. But let's talk about pre-filtration, and I think specifically, a great place to start would be the cyclones.
Right, because I think we have two areas, and you guys will be great at explaining the difference between passive versus active pre-filtration, right? And I think those are the two choices in the market right now.
Yeah, and if we look at conveying, we have two primary that we really like to offer. We have cyclonic, which is the more passive dust collection.
And why do you call it passive in that? Just explain that.
Because it's stationary, doesn't have additional moving parts, and you just plug it in line and it runs as you go.
Okay.
You don't have to have any additional wiring input.
There's no motors. There's
no motors.
Just out of there, you're plumbing it in directly.
Strictly mechanical.
Yep.
Yeah.
Okay.
And all we're doing is we're making use of the forces generated when you're forcing air through a particular line size into a larger cavity, allowing it to slow down and utilizing the weight of the material itself against those forces to separate itself into
So it
contaminant.
you're separating those materials, the dust or the...
Yes, if you picture, and I'm sure we'll put up an image here for you. We have an entryway. It could be a tube sub, it could be a boxed in inlet that comes in primarily tangential to a larger cavity, which is what we would call a chamber, and that chamber would accept that material and allow it to start cycloning in the body and slowing that material down. And then you'll enter a more of a funnel-like system that will take that momentum of the contaminant that you're trying to separate and force it down into a collection
certain
chamber.
parts of that are going to separate.
Yep.
And
So each cyclone is designed specific to a certain size of particulate to a certain efficiency.
As well as CFM level. Don't forget
Yeah,
that.
CFM level.
Obviously, each body size allows a certain CFM. So we will scale our body sizes according to the anticipated CFM.
And that's really based on deceleration you're expecting.
Exactly.
Yeah.
100%.
Yeah, I mean, we were talking the other day about some of these concepts, and I'm going to date myself a little bit, but you go back to the days when you were a kid at the carnival, and you got in that ride where you stood against the wall and it spun around and the floor dropped down, and you lifted your legs up, and as it slowed down, your butt slid down the wall and came. And kind of the same thing as the material and the air slows down, the material wants to fall out of it, right?
Yes, and then the lighter particulate in the quote unquote clean air will exit out through the top.
So you're almost de-dusting and separating at the same time.
I know we were looking the other day at, we're adding some cyclones to some of our dryers now.
Mm-hmm.
And the percentage that you were able to extract there in one of the tests, I was just amazed at. So just talk about that a little bit in terms of the separation effect.
Yeah, well, we try to base our cyclones to be able to handle at least a bare minimum that, you know, our main primary safety filters on our equipment are able to handle, but we take out the larger chunk in quantity.
Stuff that'll block the filters.
Yeah.
But I think in that test, we had almost 98, 99%.
Oh, for that particular test, yeah. So we designed a small cyclone for our dry convey system, and we were able to pull out about 98, 99% of the dust particulate that was coming through our vacuum receiver.
Amazingly effective. I mean, it's incredibly effective because I see other people that are proud to brag up 90%. But you think about still that's 8 or 9% difference there, which is a lot of dust.
Yeah, but even 90 is not bad, especially when you're extending the filter life. But every percentage that you can inch out is the longer the first. I mean,
because it's not linear. I mean, those 1% when you get up in those higher numbers makes a marked difference in the actual life of the filter.
But then, so this is the type of thing where we just we obsess on. I mean, I think Tim, you and I have talked about this lots of times. We sell a lot of cyclones.
Mm-hmm.
I mean,
we sell more cyclones than we sell pumps.
Right. We sell more than our share. So that tells me that people are using our cyclones to clean up some other issues.
Some issues, exactly. Yeah, and we have customers that we have gone into. One in Pennsylvania, for example, that I remember very well, had pumps in a pump room, competitors' pumps, and they were very, they'd been there for a long time. We sent some cyclones up there as a trial for the dry, and they put 30 of them in that plant. They were, because it wasn't that they were trying to get rid of maintenance people. It was that they couldn't hire maintenance people. They could not get people who they had enough personnel to be able to keep up with that. And this literally allowed them to keep machines running that they could not keep running before because they couldn't maintain the pumps and filters.
And that was just by adding
some passive cyclones to each of the pumps. And the investment was, is extremely reasonable, again, because it's a passive device. There are no motors to buy. There are no solenoids and things like that, which cost a lot of money. These are reasonably priced abatement issues.
Yeah, and it's not an item that has a consumable.
Exactly.
So it's a collection container. So like if you were primarily focusing on using your pump filter to filter out all that dust, you would have to clean that, and then eventually those filters get so saturated that you can't even get it back to the original state and have 100% performance, no matter how well you cleaned it. So you would actually have to replace that cartridge. Sure. By having the cyclone dust collector or any other upstream filter abatement, you will be able to extend that cartridge filter life, so you wouldn't have to have as many on the shelf. You'll be able to
save down that way.
You save more.
Practically justify it just based on the filter life.
The only thing you have to do is figure out where you're going to dump that dust after you collect it in that bowl.
Right, because there is usually a bowl. It can be sometimes I think we use polycarbonate. Other times we use
some steel buckets.
Yeah, it's reasonably large, and it's easily. You pull it down and you have to do something with it.
Mm-hmm.
And it's a lot quicker process than cleaning out a filter, unless you have a spare filter on the side.
Right. And we talked about the fact that there's, you have the option as well that we can put a slide gate in, and you don't have to interrupt the process at all.
Yeah, that's very popular on our drying sample.
Yeah, the big dryers in particular, that they never want to shut down.
Yeah.
Do that a lot.
Yeah,
just put some type of hand crank, gate in line. Sure. Take that, they'll be able to dump it, put it back in line, and they don't miss a beat.
So we call this our CDC, right?
Yep. Yeah, cyclone
does that's what it stands for, and we make it in
Any size from, I mean, we've made them, how many, 1.5 to 16 inches.
Yeah, based on line sizes.
So,
We make thousands.
right. And then we'll scale the bodies according to what that CFM level is. So, for example, we make something we generically call our 100 CFM body. And that usually gets paired with an 1.5 or 2 inch line. Something that we didn't talk about that I think is important, and Ryan and I go through this a lot, is we talk about the efficiency level of the stuff, but it's also important on what micron level we're talking about. So when you look at a filter, right, you're looking at something that might be 1 or 2 micron in a filter. So being able to separate 8 or 10 or 12 micron on a particulate level at 99% efficiency is important. So not only are we looking at an efficiency level, we're looking at a micron level. Sure. We're trying to get that micron level down, because then if I have a 1 micron filter and I have the difference between separating at 8 or 10 micron on the particulate size makes a big difference, because then your gap in between gets smaller.
The shader tends to blind that filter a lot faster.
Exactly, and that's why we're trying to get the lower micron level at that high efficiency level as part of the balance that we look at as well.
Sure.
So I only bring that up because people would be able to say a lot of times, well, we have a 99% of it.
That's your micron.
At 1 micron.
Question, yeah.
That's at 25, then that's fantastic. But we're still twice as good, or whatever it may be. So I just wanted to point that out, because I do think, because we get a lot of additional sales, it's because our cyclones are already separating at what I would consider to be almost a filter level, micron level separation. It would be a bigger pleated filter, but it's a good mechanical separation, I guess, is the point to keep in mind.
We've talked a lot about conveying pumps, because that's obviously a lot of where dust needs to get separated out in the process. We believe in this enough, and you guys know this. We don't sell a pump without a cyclone. It's part of our system.
At a bare minimum.
At a bare minimum.
Right.
You get a Donaldson filter to protect the pump. But we believe in this enough that we have priced these competitively enough where we can team them up with a cyclone and make sure that the customer gets that.
We do that in all our systems.
All of our systems. Yeah, we literally do not offer.
I would say on this side, 40-50% of our business is really systems.
Absolutely. Yeah, correct. I mean, we're fairly well divided systems to units at about half and half.
Exactly. So let's talk about what's beyond cyclone dust. The CDC. What's the next step for people to look at?
So typically we would go to what we call our FDC, which is a filtered dust collector. So now we're talking about 2 forms of separation. We still do a lower section that has a tangential entry, some level of hopefully heavy separation coming down, but also a set of filters in the upper section.
Does this use with CDC, or is it an alternative to it, or how does this fit in the?
Yes.
Depends on the application.
It could be either, right? Yeah.
Yeah. So you can do it as a complete replacement, or you can do it as a stage setup.
So why would you use an FDC over CDC, for example?
So in situations of like granulated material, high dust content, anything that could be somewhat powder related, where you need a much finer filtration. So these FDCs come with a 1 micron set of filter cartridges. So they come 3 minimal, up all the way up to our 4-inch line.
Well, and they're also self-cleaning, so high concentration.
So this is more the active than the passive.
So it blows
self-cleaning is some sort of pulsation.
Exactly.
It'll typically operate whenever our pump enters an idle mode or does not have a demand on the system anymore.
Sure. Yeah. And to be fair, most of our competitors offer some type of active filter collection, dust abatement this way. We take a little bit different approach, and talk a little bit about the fact that, the number of filters, the filter area, because that's really what I think you worry about in filtration, right? Is the square footage of filter area.
Yes, absolutely. Because let's say if you start with our pumps, just for an example, we typically have those have a 2 micron filter, paper filter. Sure. And you can imagine the size of that. Let's say 8-inch by 10 tall.
Sure.
8-inch diameter by 10 tall. If you wanted that to have the same micron rating as, let's say, a HEPA filter, which is down to 0.3 micron, you would have to significantly increase your square footage of filter area in order to have the same amount of allowable airflow through it. And you may not be able to do it in that footprint. You would actually have to either increase the height, increase the outer diameter, and maybe shrink the inner diameter in order to have enough pleats, in order to have enough surface area, in order to have the same equivalent airflow going through it. However, then you have to worry about it being more susceptible to saturating because you have that finer filtration. So then you want to oversize beyond that. So the filters that we use on our filter dust collectors are actually significantly taller with many more pleats and are actually, and this is just a little additional, they're PTFE coated polyester.
So they're not stick, right?
Non-stick. So you can actually clean them more frequently than you would with a paper filter.
And there are multiple filters in the housing.
Yeah, so 3 minimum in compared to a single paper filter in a pump.
Sure.
We standardized on that years ago only because everybody wanted that. So we offered different filter cartridges at one point, but standardized on that. And that's part of where we try to listen and watch feedback of what customers need and the applications. And just to make it that one way so that everybody got the best filter option was an important piece to us. I didn't mean to cut you off. Go.
No, you're good. But back to the Aldactive and the fact that we have those 3 filters, we have to clean those 3 filters, right? So we actually have our controls set up so that we can individually pulse each one so that we get a more effective cleaning of each. So we're taking that full...
You take more air volume through each filter.
Instead of dispersing it in each pulse where you have less pressure against.
Okay.
That's also why it's important that we have that collection bucket at the bottom, just like we do in CDC. So as they do that pulse blowback, it will fall down and collect in the bucket. And obviously, the bucket expansion, it works the same way. So you come down to a cone, and then it expands out to a bigger bucket so that once it drops to that point, there's not going to be enough vacuum suction to pull that back out of the bucket. So, we rely on those physics of airflow to make sure that once it's collected, it's not going to be reintroduced to the airstream.
Yeah, like we're on a cyclone, it's capturing primarily the larger particulate that it's designed to do. With the FDC, during that down period where we're cleaning the filter, we're actually able to allow the finer particulate that would normally be swept up in the airflow to be in that chamber.
And I know it allows us, from an application standpoint, if we've got customers who have a clean room situation, for us to be able to use an FDC with HEPA level filtration, and be able to do central conveying in a clean room.
Yeah, and the difference between a HEPA and our standard filter is very minimal. Where ours are rated down to 1 micron at 99.97% efficiency, where with a HEPA it's 0.3 micron at that roughly that efficiency or higher.
Oh wow, okay.
So we're relatively close, but yeah, we do offer that as an option for true like HEPA situations.
Medical clean rooms, food grade.
So Tim, earlier you talked about the fact that we always are going to ship our CDC with our systems, pumps installed, things like that. So from an FDC point of view, talk about some applications you've seen where we're using FDC, other than we talked about medical clean room just now.
Yeah, I mean, sometimes it's to protect the equipment, sometimes it's to protect the process, sometimes to protect the environment, obviously. One of the areas that we do that a lot is when we have PET recycling and reclaim, where we don't want to, especially in infrared type of drying situations, where we don't want to have a lot of suspended dust particulate where it will foul the process. So we do that quite often. Anything that's really a clean room type of situation, or if we've got a customer that's got a lot of very, very fine particulate, Ryan mentioned, it doesn't necessarily just have to be a powder material, but really even like talc-filled polypropylenes where the talc is going to separate during conveying from and then we'll want to filter that out and protect the equipment and protect the process. So there are a number of different scenarios where that would make sense. And I think Greg just ran into a scenario that you mentioned before where it was teamed up. It was an FDC in front of, or a CDC in front of an FDC.
Yep.
So cyclone and then a bulk.
They wanted to do large separation, they did finer separation. And then even while there, we kind of brainstormed through the situation with the customer because it was just like, I can change it over, but part of the problem is, I don't want to be down for that 10 minutes that it takes me to do that. So can you put a bypass in? And we're like, well, we can do that. But obviously for that 10 minutes,
You're going to blow
we're going to blow it by to the pumps.
Yeah.
So we came up with just, real simple solution was just, these 3 plates that Ryan's referring to were on one mounting plate. So there's a lid that comes off. Typically they would take that out, blow these off, try to clean them up, and then put them back in. And I just said, what if we just give you a whole second plate that has 3 fresh filters on it?
Pull it out.
So you pull it out, put the new one in, put the lid back on, and you're talking about 90 seconds instead of 10 minutes to pop that and get that. And then now you can just clean those at your leisure and have that ready for the next one. And they had probably a half a dozen of these things. Wow. So just to give them a set, to be able to do that, where they have a couple of spares and they go down and have some clean and some to be able to do that.
Sure.
And, so their bypass is still going to get done, but it's only going to get done on a very short window to, again, and try to protect that pump because, it is the heartbeat of the system.
Well, one of the things we haven't talked about. Oh, go ahead.
I think we're probably on the same page here is the fact that when you're talking about being down, like the customer has to be down to 10 minutes to clean those filters, they also have to end up cleaning those buckets too.
Absolutely.
And there are other configurations of both our cyclone dust collector and our filter dust collector that will actually extend that maintenance interval as well, because it's able to do a drum dump or in some situations a Gaylord dump, which is more specialty if you have.
Really, when we get to the real extreme, we've done some that actually have a vacuum port on the bucket, and you never shut down. You just turn a vacuum on and it sucks everything out. Yeah, essentially.
Yep.
And then I think the other time where we really see a good application of FDCs is when we've got, and many plants have this situation where they've got receivers and central conveying components that are really inaccessible. And so, you're up on top of a big vessel of some type, either a drying hopper or a surge bin or something of that nature. And you're up in the purlings of the ceiling because nobody has enough overhead height. And so we many times put a filterless receiver up there, not wanting to catch anything at the receiver. If the customer wants the dust out of the process, we actually, by intention, allow it to come back to the central process, and then we filter it out with an FDC, essentially, so that the customer doesn't have to try and maintain a filter up in an inaccessible area. So that'd be a safety issue. Exactly. Yeah. So we do that quite often as well with those situations. Yeah.
So obviously, both the CDC, FDC products we make right here in Baltimore.
Yep.
Sold, obviously, comes out of both our plants in Pennsylvania and also Maryland. But it's a product that we fabricate. We roll the steel. We weld it, put it all together.
Yep.
Our design.
Our design.
Yep. And it has been, those are tried and true designs that have been around for as long as I've been here. So, I mean, I think that's the real testament. I mean, there's a lot of times where you kind of update and refine and
make something a little better, right?
But haven't had to. I mean, that's the amazing part. The design of our CDC is 100% the same as when I got here. And have we changed it to make it easier to fabricate or do stuff or, tab the notch to this or that to help our welders? Sure. Absolutely. But have we changed any of the specifics of the engineered pieces that allow the speeds or the feeds or the way that things drop that? Not a bit. So, I mean, that is a 100% tried and true.
Because the only thing that's changed over the years is sizings.
We've
line sizes.
Right. We've expanded over the course of the lines. But, the general dynamics of the way that it operates, we've expanded through every conveying line size and every drying line size that we do across the board.
Well, Conrad, you mentioned something that we kind of didn't really talk about, but that is a real source of pride for our people out in the field when we're dealing with customers, both our distributors, our representatives, and our own people, which is, all of the products we're talking about are 100% American-owned, American designed, American built. We don't outsource things overseas for cheaper manufacturing and bring whole units in and so forth. Certainly components, everybody gets them globally, and that's understandable. But we truly are, as you know, a U.S. owned and U.S. manufactured
one of the few, one of the few anymore.
And so that's been a tremendous source of pride for our team, and we continue to really make sure that our customers understand we can support you because what we do is here.
Yeah, and if we can do something better, we can go back and we can fabricate it.
Exactly.
Like Greg was talking about, putting the additional assembly and having a backup assembly.
Yeah, I mean, we just had that situation, and both of you are aware of this, where we're trying to fit things into places that there really is no room.
Yeah. No room at all.
And so we've got a lot of units where, even this this situation where we're talking about cyclones, we've got a great unit for companies that have to put pumps into an area where they're really not accessible. Nobody wants to go in a pump room to start with. But there are some which truly are just difficult to access, to maintain at all. And so we have the option. We brought this challenge to Greg and his team and said, customer would love to have a cyclone, but they still can't get to the darn filters because the pumps are here. And the answer is, well, great, we'll bring the filter to them. And so we've got a remote filter mount that can go right on the cyclone. And so you get both filtration components right in an accessible area. So again, if we'll bring them out to Muhammad if that's what it requires.
So beyond the CDC and the FTC now we just covered, what's next in terms of filtration? What's out there, Tim?
I mean, there really are a number of things that that we're working on, but I don't know what Greg, you're probably a better, I guess, judge of what you...
With filtration, for example.
Yeah, I mean...
Where does that fit in?
Oh, okay, I'm sorry. So I misunderstood your question. So, active filtration and active dust separation is certainly a whole area of expertise. And there are great companies that we partner with. We don't do those things. And again, goes back to kind of staying in our lane.
Right. But that's also their lane. That's what they
see. Exactly. As you and Steve have always said, we want to do what we do well, and we want to know the guys who do everything else well. Right. And so, in small filtration and dust separation, a lot of the industry goes to companies like Pelletron, where they, and they are based on dropping through and redirecting the flow of material. And as they do that, they blow air across and separate the dust. And then in larger throughput, our go-to partner is usually Kongskilled. They have a very effective elutriation system for granulation, for large volume separation. And again, those companies, because we work with them directly, they understand our applications, we understand their capabilities, and so we get to do the engineering for our customers. They don't have to go figure that out. They give us the challenge, the application, and we're able to work with those companies and let them degree those.
The price point is vastly different. Obviously, CDC might be a few $1,000s, and
you're talking about probably $20,000 or $30,000 for an elutriation system.
10, 12 times.
Absolutely, yeah. And it's because, like we talked about earlier, those systems, as they get more complex, have a lot more componentry and so forth to them, motors and controls and so forth, that just drive the price up. And for a standard separation challenge in drying or in conveying, probably not necessary 90% of the time. It's that 10% where it really is, that's the only way and the best way. We make sure that we maintain those relationships where we know where to go.
Exactly. Over the years, my experience, I think, the two of you, in the vast majority of the marketplace can be cleaned up by CDC, FTC type applications.
Yeah.
So that's what we default to first.
Exactly.
A lot of people don't take advantage of those systems because they don't know they're there.
Mm-hmm.
And we still, like Tim brought out earlier, we retrofit our cyclones into many competitive pump room situations.
Yeah.
For exactly that reason. People don't know they're there. They should be there. They haven't been sold that way. People don't think they always work. Ours does absolutely work.
Well, and it's been a real help and a blessing for us out in the field that, you and obviously your partner, Steve McGuire, are big believers in maintaining inventory. So we can ship things quickly to people, but because we have inventory, we have the ability because we believe in these products, to say, you know what, let us ship one to you. Let's help you put it in.
Right.
And we're not afraid of getting it back because, one, it's a great product, we'll take it back. But more importantly, because we don't think you'll want to give it back to us because we know they work. And so that's been very, very helpful. And we certainly would offer that to any of our viewers.
They were extremely low payback period
Exactly.
for a product at that end. In the FTCs, even though now you're getting more involved and so forth, still it's a very low cost investment compared to a lutriation.
Well, and
over time, for sure.
cyclone dust collector as opposed to filter dust collector, from a volume of what we do, we're probably talking about 5%. Yeah, I mean it's tremendously. We'd sell 20 cyclones to one.
No, it's amazing what the CDCs can do.
They're so effective, and we're very fortunate to be able to do most of what we have to do in that.
If those folks listening to us haven't taken advantage of this, something they should really look at.
Absolutely.
Yeah. So we're starting to the end of this podcast.
Mm-hmm.
Let's talk about what's the next step for customers that are interested in having a further conversation, talking about their application from a sales point of view or from a product point of view.
Mm-hmm.
Who do they call?
So we've got we're very blessed to have a tremendous network of partners out throughout the United States, Mexico, Canada, and that's one of the big changes that we have seen over the 20 years that we've been here is our partners and our distributors, our representatives are really, at a level where they're factory people. I mean, they're so well versed and so well informed. So, either any of our customers or our potential customers can reach
our
out.
Rep and our map.
It's
So
on the Novatec website, right?
It's on the website, but it'll be on a graphic within the podcast.
Exactly. And they can reach out to any of the reps, or we've got remotely located systems experts, and all of we don't have systems salespeople. I always say that we have systems engineers that just happen to be able to sell you something,
right?
And they're more than happy to come to your plant and take a look at those things. So Novatec.com, they can find the most convenient contact for them, or they can just email us through there, and somebody here in Baltimore will get that communication. We'll reach out.
If they want to have conversations, obviously, any of our regional engineers, as you say, are based regionally around the country.
Mm-hmm.
Our product teams back at the factory.
Yep.
Ryan and his group are available as well.
Yep.
That's the best place to start, right?
Yeah, no doubt. And again, that's one of the things that we're very fortunate about is the people that are within our company understand the process. They understand the customer's process and what drives their profitability. Because we all understand nobody's in this just to make parts. We're in this to make money in the parts of the vehicle.
So if you were looking at an application that a customer was going to call up and talk to us about, what's the information they need?
That's great.
They make that call.
Yeah, that's a great question. And Ryan, you're probably best to answer that, but certainly, CFM of the process that they're trying to separate. What else?
We get a good idea of what your pump equipment is, what line size you're working with, and the CFM of the pump itself. That is usually enough information for us to determine what size cyclone that would be effective. Whether we can use one of our standard sizes that match our equipment line size, or if we have to step up or step down depending on the CFM requirement.
And certainly we always welcome people to send us a sample of their material or of just the dust that they're trying to separate, and we can kind of look at the particulate size and the volume and so forth.
We run tests here.
Well, we're blessed because we have this great lab here where we have a true conveying system already set up in our lab. And conveying and drying systems.
Yep.
So
from
love having people send it in. Yeah. So they can send their material here. We can show them what the cyclone will do. We certainly always welcome people to visit. We're very fortunate. We're 3 miles from BWI Airport, which is a great hub airport. Happy to pick somebody up at the airport and they can come in and watch their material run, and we'll show them what we can do.
Or if they send here, we can always videotape it.
Absolutely.
Get them information. But
flexibility.
Like I said before, this is the type of thing we do all the time.
Yes.
Sold thousands of these. It's what we do. And I think in wrapping this up, this discussion today should be an example to everybody of how we just sit around. We can talk about this stuff. We obsess on it. It's in the soul of this business. It's in the very blood of the people that are are sitting here today.
These are everyday conversations that we have. I mean, this is nothing we don't talk about every day.
One of the things that's really struck me in the last 2 or 3 minutes that I think is just different about how we do stuff is just the integrated team, from the reps to all of your guys to everybody that's here. Is we approach this as one collective group. It doesn't get dumped over some magical wall of a silo that's a sales issue now, or I'm waiting, you know. It's everybody taking a few steps, having a conversation. I mean, you know, that's the beautiest part is I'll walk back from the shop and you'll grab me and say, come here a minute, and we'll have a conversation. And then, you know, Ryan gets involved. You know, we get a couple emails going, we set up a phone call, Teams call, whatever it is, and get stuff done collectively. And I think that's doesn't always happen in this day and age, particularly at a lot of places. But I feel like it is a core strength of this group to attack stuff as one team, and we do it every single day.
Mm-hmm. One team and focused on a very small group of applications and conveying, obviously blending for our partner company Wire, and finally drying. Yep. Okay. It's what we do. We obsess over that. It's what we could talk about, probably so we can bore people for hours and hours if we have to, but we're trying not to do that.
We're not the most riveting cocktail party.
No.
You start talking about this, right?
We have a little beer here, but it's what we do. It's what we focus on, and it shows in the products that get out to the field.
Yep.
So we thank everybody for tuning in today. We hope you've enjoyed this podcast. We're calling it a podcast. Over and above, if you look at most of the ways things are communicated in this industry, they're through webinars and things like that, and somebody gets up in front of some expert, and it's a one-way dialogue. And
my old saying of show up and throw up.
Show up and absolutely throw up.
Yep.
Okay? And this dialogue, you get some backgrounds, you get the skill sets and the experience of all the people sitting in this room, and that goes in the products, but most of all, it goes to you. So in the future weeks, we'd love to hear from any of you out there. Tell us what you think of it. Tell us about other subjects you'd like us to cover in our areas of conveying, blending, and drying, so we can address them. We plan to do this on a regular basis. The group of three will be back. We won't always have Ryan in the hot seat here, and he'll go back to solving a bunch of problems, I'm sure, that he's waiting for right now, eagerly. Because he has a long list of things that we'll probably talk about later this week.
Well, and as you alluded to, Conrad, I mean, I would welcome anybody who's listening to or watching this podcast. You know who we are now,
right?
You know who there's no wizard behind the curtain. No, Conrad is here. Myself, Greg, you know who we are. Our phone number is on the website. By all means, look up the phone number, call our line. You'll talk to Diane when you call. She's wonderful. And say, you know what? I watched the podcast. I need to talk to Conrad about a problem. And Conrad will answer the phone, I promise.
And if not, I'll hear about it from Sid. So I'm there. We all run this business through a bunch of spreadsheets. We're running it through products and people.
Exactly.
So, and we thank you. All our customers are on, all our reps and distributors that are out there. We thank you for all your business, and we look forward to many more years of doing that right here in North America.
Absolutely.
Okay. Cheers.
Cheers.
And once again, happy 11.
Thank you.